just like the previous section where we did the addition and subtraction or product sum formulas, this one you'll get to have the formula sheet on your test, so you don't have to memorize the half angle, the double angle, or the power reducing formulas. So yay, you just have to know when and how to use them. Our goals are to determine exact values and to verify identities, just like they were for that last section. So I'm going to keep my little cheat sheet nearby. Here are the double angle formulas. Sine of 2a is 2 sine a cosine a. That one I memorized whether I want to or not because it's so easy. Cosine of 2a, it has some different options. You can have 2 cosine squared a minus 1. And that's a typo. I will fix that. You can have 1 minus 2 sine squared of a. Yes, this cosine of 2a shouldn't be there. I had combined it all into one unit. So here's the correct 2 minus cosine squared a minus 1, 1 minus 2 sine squared a, and cosine squared minus sine squared. You don't have to memorize it. It's all good. Oops. Half angle formulas. Now you notice they have plus or minus in front of them. You'll have to figure out whether it's positive or negative depending upon where your angle lives. And then the power reducing formulas. Sine squared and cosine squared are going to be really important for you when you get to Calc 2. So make peace with the fact that eventually you will be memorizing those, but for now you get to use your sheet. So let's determine some exact values. Example 1a. We want the sine of pi over 12, which is the sine of pi over 6 over 2. So again, you have to remember your fraction arithmetic for these. Sine of a over 2 would be equal to plus or minus the square root of 1 minus cosine of pi over 6 over 2. Now, pi over 12 lives in quadrant number 1, so we know that this means it's going to be positive. So it's going to be positive square root of 1 minus cosine of pi over 6, the square root of 3 over 2 divided by 2. Now you're going to have a radical inside of a radical. I know it's ugly, make peace with it, it's okay. But I don't want a fraction on top of a fraction, so multiply numerator and denominator by 2. You get 2 minus the square root of 3 over 2 times 2 is 4. And you can rewrite that as 2 minus the square root of 3 underneath a radical on top of the square root of 4 is just 2. Doesn't look all that pretty, but it's a perfectly good answer. Cosine of 22.5 degrees. That would be the cosine of 45 degrees living on top of 2. So we look up here, and you notice these look a lot like these power reducing formulas, just in the opposite direction. So we have plus or minus square root 1 plus the cosine of 45 degrees over 2. Again, 22.5 degrees, cosine is going to be positive. So this would be positive square root of 1 plus square root of 2 over 2 over 2. Multiply everybody by 2. So I get the square root of 2 plus the square root of 2, living on top of square root of 4. I'll go ahead and leave it under the radical, and then write it again with 2 plus square root of 2 over 2. Yeah, you don't have to write that in 2 steps if you don't want to. C, we have the negative of the tangent of negative pi over 8. Now, I remember my odd and even identities. Tangent of negative pi over 8 is the same thing as the negative of the tangent of pi over 8. So now I have minus minus. So this is just the tangent of pi over 4 over 2. And tangent of pi over 2, you have 2 choices. I'll just go with the first one. 1 minus cosine of pi over 4 over sine of pi over 4. So 1 minus square root of 2 over 2 divided by square root of 2 over 2. Multiply everybody by 2. I get 2 minus square root of 2 over square root of 2. And if you rationalize the denominator, you get the same thing that you would get if you did sine of A over 1 plus cosine of A. Let's look at the pretty answers. There we have sine of pi over 12, cosine of 22.5, and yeah, I didn't simplify it. You could have simplified it to square root of 2 minus 1. Okay, your turn. Give these a try. We'll meet back. We'll compare answers. How'd it go? Not bad. So again, pi over 8 is pi over 4 divided by 2. I know that lives in quadrant 1, so it's going to be positive square root of 1 plus the cosine of pi over 4 divided by 2. Multiply everybody by 2. Sine of 15 degrees, well, that's exactly the same as the sine of pi over 12 degrees. So I did the exact same thing. 1 minus cosine of 30 degrees divided by 2. And since it's in the first quadrant, sine is positive. I expect tangent of 3 over 8 to be a positive thing because 3 over 8 is less than pi over 2. 3 pi over 8 is less than pi over 2, so it's in quadrant 1. And yes, I have 1 minus cosine of 3 pi halves divided by sine of 3 pi halves. So 1 minus a negative thing divided by a positive thing gives me a positive thing. So, unknown angles. So kind of like the last section, we started with the special angles, then we went with the ones that we had to use the Pythagorean identity to get our alphas and betas. So we'll start by getting our alphas and our betas and a sheet of paper. So this is example 2. I have sine of alpha is equal to 7 over 25, and pi halves is less than alpha is less than pi, which means I'm in quadrant number 2. So cosine will be negative, tangent will be negative. Sine squared of alpha plus cosine squared of alpha is equal to 1, and sine of alpha, 7 over 25. So that's 49 over 625. So cosine squared of alpha, if I remember correctly, is going to be 24 over 25. Let's see, 625 minus 49 equals second square root, second answer. Yep. Square root of 625 minus 49 is a perfect square. It is 576 over 625. So cosine of alpha is negative 24 over 25 because we're living in quadrant number 2. And tangent of alpha is negative 7 over 24 because the 25s will cancel. And now I have everything that I need to do part A, because part A just asks me for the sine of 2 alpha. I didn't even need tangent. I just needed 2 sine alpha, cosine alpha, which would be 2 times 7 over 25 times negative 24 over 25, which would be 2 times 7 times minus 24. 2 times 7 times 24 equals negative 336 over 25 squared, 625. And let's see, there's the pretty solution. Oh, I lost my minus sign because we are in quadrant number 2. I will fix that. We have it right here because if alpha is between pi halves and pi, then 2 alpha would be double everything between pi and 2 pi. So we expect it to be a negative thing because it would live below the axis. So I have to fix that. Let's look at beta. We have b, and cosine of beta is equal to negative 5 over 13, and beta lives in quadrant number 3. It's less than 3 pi halves, which means quadrant 3. So 25 over 13 squared plus sine squared of beta is equal to 1. So sine squared of beta is equal to 1 minus 25 over 169, which is 144 over 169. So since we're in quadrant number 3, sine is also negative. So sine of beta is equal to negative 12 over 13. And tangent of beta is equal to 12 over 5. Negative over negative is positive. The 13s cancel. And I'm really interested in tangent of beta over 2. Tangent of beta over 2 would be 1 minus cosine of beta minus negative 5 over 13 divided by sine of beta, and sine of beta was negative 12 over 13. So I'll multiply numerator and denominator by 13. That gives me 13 plus 5, living on top of 12, which is 18 over 12, which is 3 halves. which is exactly what we have there. And let's see, since beta was between pi and 3 pi halves, just a little error checking for ourselves, then pi halves is less than beta over 2 is less than 3 pi over 4. So beta over 2 lives up above the axis. That seems like it should have been negative. It was negative. Look at that. Look at that minus 12 sitting there that I just ignored down here. That's a negative 12. That's a negative 12. That's a negative 3 halves. See, it's a good thing I did that error checking that told me that beta over 2 needed to be in quadrant number 2, so tangent needed to be negative. Always do that error checking. You never know what you'll find. So, practice and do that error checking. Make sure you got them right. Okay, yeah, these were pretty challenging. Let's look at them. We had cosine of alpha over 2. So I figured out sine of alpha is negative 5 over 8. That was given to me. And we're in quadrant 4. Quadrant 4 means we're between 3 pi halves less than alpha, less than 2 pi. So in quadrant 4, cosine's going to be positive. And so sine squared plus cosine squared is 1, 25 over 64. And I don't get a nice pretty whole number this time. I get the square root of 39 over 8. So tangent is negative in quadrant 4, and it's negative 5 over the square root of 39. Cosine of alpha over 2 plus or minus square root of 1 plus the cosine of alpha divided by 2. So since cosine is in alpha over 2 lives between 3 pi over 4 and pi, we're in quadrant 2, so my cosine needs to be negative, and I did some manipulation there to get it to look a little bit prettier. Tangent of 2 alpha, well, I look at tangent of 2a is 2 times the tangent of alpha over 1 minus tangent squared. So 2 times tangent of alpha over 1 minus tangent squared. And again, I had to do some squaring. I square a negative, it becomes positive 25 over 39. I have negative 10 over the square root of 39 living up top. I do some simplifying because I just do this subtraction here. I get 39 over 39 gives me 14 over 39, but I'm dividing, so I invert and multiply. So square root goes into 39, leaves me with square root of 39 on top, and then I wrote my fraction in lowest terms. Cosine of 3 alpha, I had to write as 2 alpha plus alpha. So I had cosine of 2 alpha times cosine of alpha. There we go. Minus sine of 2 alpha times sine of alpha. So I had to use that sum identity from the last unit. And then cosine of 2 alpha, I chose 2 cosine squared minus 1 times cosine, and then 2 sine cosine times sine, and I did some arithmetic and ended up with an answer. That was a lot. Next, we'll look at example 3. I've written down the identity. Now I'm going to start with the more complicated side. So cosine to the 4th of theta minus sine to the 4th of theta. Now, I did it on the slide using the power reducing formulas. But as I was looking at it, I thought, well, why not just acknowledge that this is cosine squared of theta squared minus sine squared of theta squared, just like I did here. But this could be written as cosine squared theta minus sine squared theta, this is a difference of two squares, times cosine squared theta plus sine squared theta. Don't need that extra parenthesis. Well, cosine squared theta plus sine squared theta is just equal to 1. Cosine squared theta minus sine squared theta is equal to cosine of 2 theta. Oh, look, that's exactly what I wanted. So I took a longer route to the correct answer when I typed up my PowerPoint. Okay, example 4. Let's verify the identity that tangent of 2 theta. So example 4, tangent of 2 theta is equal to 2 over cotangent of theta minus tangent of theta. Complicated side, let's start with that one. And I'm going to write it as 2 over cotangent would be cosine of theta over sine of theta minus sine of theta over cosine of theta. Now let's think about, my goal is to get to tangent of 2 theta. And tangent of 2 theta looks like that. 2 tan theta over 1 minus tan squared. This doesn't look anything like that. So let's think about getting rid of those ugly fractions. We have a fraction over a fraction. So let's multiply numerator and denominator by cosine theta sine theta. Then that leaves me with, when I multiply down below, I have cosine times cosine, which is cosine squared theta. I have the cosines cancel, and I'm left with minus sine squared theta. Oh, wait. 2 cosine theta sine theta is equal to sine of 2 theta. And cosine squared minus sine squared is cosine of 2 theta. And sine over cosine is tangent of 2 theta. So now I'm really happy because it all worked. All I had to do was get my common denominator. Take a few minutes, try these two on your own, and then we'll come back and compare answers. A was quite simple. I started with 1 plus sine of 2 theta, and I just wrote that as sine of theta plus cosine of theta squared. I just wrote down the formula. So I actually started with this side. I squared it. Sine squared, 2 times the first times the last gives me the plus the last term squared. And then I put the sine squared plus cosine squared together, and that's equal to 1 plus 2 sine theta cosine theta is sine of 2 theta. Not bad at all. Part B, I didn't write down the whole thing first. So I just wrote down cosine 2 theta cosine theta. But cosine 2 theta is cosine squared minus sine squared times cosine squared. And then I distributed, gave me cosine cubed minus sine squared cosine, which was exactly what I wanted. power reducing formulas. So these are the ones that you will be using a lot in your future in Calc 2. Write an equivalent expression for cosine to the fourth that does not involve powers of sine or cosine greater than 1. Example 5. So cosine to the fourth is the same thing as cosine squared of x squared. Well, cosine squared is 1 plus cosine 2x living on top of 2 squared. So that would be 1 plus, let's see, I think I'm going to go ahead and square and put it over 1/4. I don't want to lose anything. So now I just have to square the 1 plus cosine of 2x. That gives me 1 plus 2 cosine 2x plus cosine squared of 2x. Okay, so far so good. So I decided to square the numerator and square the denominator separately so I didn't lose anything. So now I'm going to divide it into pieces. I have 1/4 plus cosine of 2x over 2 plus 1/4 times cosine squared of 2x would be 1 plus cosine of 4x living on top of 2. So that would be 1/4 plus cosine of 2x over 2. I have 1/4 times 1/2, so that would be 1/8 plus cosine of 4x living on top of 8. And I have 1/4 plus 1/8 gives me, let's see, 1/4 would be 2 over 8 plus 1 over 8 gives me 3 over 8 plus cosine of 2x over 2 plus cosine of 4x over 8. Let's see how I did. 1/2 gives me 3/8, 1/2. Yay, we did good. One last one for us to verify, then we'll come back and compare. 10 cosine to the fourth is equal to, so I would do something similar to what we did just there. It worked exactly like the one before. You actually could have just taken the one before and multiplied it by 10 and gotten there. But just for practice, I went through and did it again, squared this. I brought the 4 out with the 10, then I rewrote it as 5/2, distributed, did the angle reducing formula again, and ended up with exactly what I wanted. So, getting exact answers and verifying identities. You can do it. We've got one more set of identities to learn, and then you'll have them all ready to go.